The arrival of monsoon across India is a huge relief both from heat and water shortages. But this is exactly what makes us negligent. We forget how cities like Bengaluru and Delhi have suffered acute water shortages this summer. How Delhi Water Minister Atishi was hospitalized due to hunger strike demanding that Haryana releases the additional water owed to Delhi. But Haryana too is struggling with water shortages, and water mafia has made life difficult for residents of Dwarka Expressway. We won't remember very soon anymore that Moody's, a leading global credit rating agency, has warned India's sovereign credit strength could be impacted with water shortages because it affects agriculture and industry. India's perception as a place to invest in and do business will suffer. 2024 has been the hottest year ever recorded globally and in India as well. And this precious source of life, water, is going to get harder with each passing year. In fact, in 2018, Niti Aayog raised a red-hot alarm saying India is suffering from the worst water crisis in its history. 8 years later, the water shortage situation is even more out of control. Yet the political response, the response of urban water regulators and citizens' own commitment to conserving water, recycling it, recharging water remains deeply disappointing. Anyhow, enough of the problem. Are there solutions? Yes, there are. Plenty. Today on the Urban Agenda, we bring you face to face with tech and AI-based solution providers and startups who are working on tracking water usage, water recycling, and even capturing water from air. Swapnil Shrivastav, CEO and co-founder Uravu Labs, joins us. Nikhilesh Kumar, CEO of Climate Tech at Vassar Labs, is with us, and also Amrit Nayak, co-founder and CEO Indra Water. And all three are doing very interesting and different sort of technologies. Let's start with Vassar Labs. Nikhilesh is with us. Vassar is a technology company that focuses on providing data-driven solutions for water management. Nikhilesh, just break it down for us. What are these management solutions and how do they really help in avoiding water wastage and how do they conserve water?
So what we are doing is we are providing real-time information on water availability, water budgeting, to identify where the surplus water is, estimate the flood water, and precise points where we can conserve it, how we can recharge the groundwater, what is the current situation of groundwater in every city, every region, every river basin, and at a country and state scale. Now, water is a subject of state, so every state needs to know what is the total water they have and what's the water allocated across different sectors. So we help in monitoring, we help in doing a real-time assessment across the hydrological life cycle, across the different demands, across different sectors, and how they can plan in terms of mitigating any risk, any adverse situations like water shortage, but also on knowing the disasters of floods and managing overall water distribution, water storage, and water transmission. So that's the nutshell.
And does the technology also help you detect water leakages in, let's say, a municipal corporation pipe?
Yes. So within a city distribution systems, right from source monitoring to treatment plant to individual houses, we help in tracking the water as it goes to thousands of houses and as it flows into the pipes and treatment plants where the water is. We do water audit across the network to understand where water is leaking, where are the NRW, where are the losses, and how you can minimize them.
All right. Okay, I'll come back to you on how widely is this getting deployed and what can you do for Delhi because, or a city like Bengaluru. Amrit, let me come to you. Indra Water, very well-known company, develops advanced water treatment to recycle and reuse water, which is, again, such a big thing. I mean, something like an RO in a day for a family of 6 people is 3 buckets of water wasted. Give me a sense of first the technology, and if I give you, let's say, 100-family residential colony, tell me what can you do?
No, thank you so much. Indra basically treats water at the point of source using electricity. That's where we really differ from others. Because we use electricity, we can break down some of the most difficult pollutants. And I mean, it can range from heavy metals, pathogens, oil and grease, or even nutrients in water, which are toxic to human beings. When we break down these different pollutants, we do it in seconds, unlike conventional solutions, which requires hours or days to treat water. Hence, today we're able to build these plug-and-play solutions, put it into every building, and ensure that water gets reused at the point of source. We're able to recover up to 99% of the water without rejecting anything. And all this while having a 74% carbon offset. So that's actually contributing, cleaning up everything. For let's say 100 family thing where we have 300 residents, I think we should be able to treat a lot of water and offset 80% of their daily water demand for non-potable use applications, which means they could do their flushing, their gardening, floor washing, car washing, all of these activities. And then higher quality water could be provided for the remaining 20% at a much lower cost. We should be talking about at least 30% cost savings, and more importantly, 80% offset of freshwater demand. So that can be very impactful. What I would say is that today Indra is able to recycle black water, grey water, and industrial effluents to the most advanced NGT norms, meet norms even in Singapore's PUB, or meet Australia's advanced norms. So technically, we understand that a lot of buildings do not have segregation of water. It's pretty difficult to build pipelines all across.
Right.
So Indra is taking the water as it comes and cleans it to desired standards.
And how large is the unit? Is it compact enough to be deployed by residential projects across India?
Yes, it's very, very compact. In fact, I would want to say that we would occupy just 50 to 60 square feet of space for the 100 families you just mentioned.
All
and I think
right.
that's something which everybody can give.
Okay, so that's what Indra does. Let me now come to Uravu Labs. They specialize in atmospheric water generation. That is, they capture water vapor from air and condense it into clean drinking water. Swapnil Shrivastav, what is the technology? And my most important question to you is, as the temperatures rise in dry places, will it still work? Will you still be able to capture?
Sure. So first of all, thank you so much. Just to give you a glimpse of the technology, we don't do like a very basic condensation process, which is very prevalent in many products out there. What we essentially do is we use a material which is a salt solution, and this absorbs moisture from the air. And over time, the salt solution will increase in volume. Post that, we apply heat energy at about 60 degrees Celsius, which can come from variety of renewable energy sources like solar, and we can even use waste heat from industries to power the device. And upon applying this heat, all the water vapor which was earlier absorbed gets released almost in a steam-like form, which we then collect as high-quality pressure. Now, the advantage of this process is that depending on the relative humidity of the place, so say you go from a coastal area to a drier area, we can change the amount of desiccant or the liquid salt solution we use to give you the same output of water. So regardless of drier areas, you can still get a reliable source of water where there's no wastage, as well as you get almost like high quality ultra pure water, which either you can use for drinking purposes after adding essential minerals, or you can directly use this for industrial purposes.
Do you think that these are at a price point that residential colonies can adopt, or do you think this is something that only commercial establishments and maybe government, if it decides to, can adopt?
Sure. We have been on a journey of reducing this cost curve. We started around 4 years back when we were at 6 to 7 rupees per liter. Now we have brought it down to 2 to 3 rupees per liter. But the idea is to scale it to a price point where it's below 80 paise to 60 paise per liter. So once you hit that price point, what happens is a lot of applications open. So while today we are looking more at the hospitality sector and working with hotels, restaurants in Bangalore, and helping them save almost 1 million liters of water in the past 10 months. The idea is to then eventually scale it and lower the cost so that it can be widely used and made affordable for a lot of applications.
All right, Nikhilesh, I'm giving you New Delhi. First of all, it has your technology, which is AI, IoT based, geospatial survey based, where you can map out a city's entire water network and then drive efficiencies. My question is, have cities like New Delhi and Mumbai, let's say Bengaluru, adopted your technology? Do you have any successes there?
So not to New Delhi. So we are not working with New Delhi. Majority of the city, I think it's not a problem of New Delhi or any a name city. All the urban city would eventually fall into this crisis for some short period of time over the entire year. And one of the very critical component or part of the story of this crisis is groundwater. So just to give you some stats, Delhi, or rather you take Bangalore, Chennai, Hyderabad, 50% of their region is already in an overexploited situation with respect to groundwater. So let me just explain what overexploited mean. It means the amount of water that goes into the groundwater and the amount of water that we extract. So we are extracting more than
Yeah,
what is
very
going
well
in,
known fact. Yes.
and over the year it is going to touch depletion point. And where does the solution lies is, I would say, in a threefold mode, very similar to taking a science and data approach. Technology needs to be brought in to drive first reduce. So how can we reduce the losses? How can we reduce the demand,
Okay.
especially during the peak crisis situation? So there is a demand peak up, but how can you reduce it? And then the other area that we can impact is, how do we recharge? So how do we recharge, conserve the flood water or storm water or the reuse component of the water and still recharge the groundwater, which actually can come handy during such a
Of
period.
course.
You don't need to
Absolutely.
depend on other areas, but groundwater is right below you, which can be used during the crisis. Also, the reuse component. So, how do we identify what component of gray water, even sewage, can be reused back into the system and drive? To do this, more detailed mapping of all the water cycle is required, and you need to have a system where you can make these decisions.
And you do
So we
have
have
that, you
done.
provide that system. All right, Nikhilesh, how wide is the adoption? You said Jal Shakti you're working with, Hyderabad you're working with. We'll come back and ask you, what else do you need to crack? How many more people need to adopt the technology or technologies such as yours? Stay with us. We will keep this important conversation going on the other side of the break. Rivers are polluted, groundwater levels are depleting, traditional water harvesting, rain catchment zones are lost to construction, and water bodies like lakes are disappearing. Bottom line, water is one of the biggest challenges globally and in India, and cities going dry is only likely to get worse if we don't wake up. So, today we are focusing on solution providers who are solving for water. Amrit Om Nayak. Recycling water, there is a lot which can be done globally. It is getting done, and like you said, that you can, it's not just grey water, you have the technology to even recycle and make potable black water. So here's my question to you: how wide has the adoption been in between government, commercial institutions, or let's say industry, and residential of Indra's technology?
I think Indra's technology is pretty powerful in breaking some of the toughest pollutants. So we started with industries because you have a very high concentration of pollutants going into the freshwater bodies there. And I think we have treated over 1.5 billion liters of water. And I mean industrial wastewater there, where we have managed to reduce about 8,000 tons of solid waste or sludge with our technology. We have reduced 5,000 tons of chemicals from being used in wastewater, which are generally harmful, and also offset 1,300 tons of greenhouse gas emissions. When it comes to government, Indra has taken a cautious approach, and we want to slowly scale up our engagement with them step by step. With commercial and residential societies, we've been focusing on the commercial establishments more, which means hotels or software parks, IT parks, malls, retail outlets. Now, these are places where we're able to create a massive impact. There is a lot of variation in the kind of water seen. So our technology, being electrical, can very quickly adapt to these changes, and that allows us to treat this water very effectively. So over a period of time, we are starting to roll out paper litter models for sewage treatment, which will allow people to, just pay for the service of clean water and the amount of water that they actually use at the facilities.
What are the barriers of expansion? Is it your own ability to produce the recycling units, or the price point, or do you think people just need to know more about it?
I think it's a mix of all. Of course, as a growing company, we are trying to produce more. We're trying to increase our capacity in terms of execution, customer support. So those factors do come in. But more importantly, it's about awareness and the right price for water that has to be paid. In fact, in India, water is charged volumetrically, which actually does not incentivize somebody who is generating large volumes of water with lower pollutant load to actually treat it. Whereas people should be charged on the basis of pollutant concentration and the volume of water that they're actually releasing as wastewater. And this disparity results in a slower adoption rate in general. We are, however, seeing this whole trend change a lot. We're seeing adoptions really skyrocket because water scarcity, change in availability of fresh water, and more importantly, the difficulty in treating the new evolving pollutants with existing technologies. All of these are driving adoption rates with our technology.
All right. Okay, let's close this discussion with Swapnil. Uravu, what are the plans of expansion? Are there any barriers, policy level, in terms of adoption, or do you think that is your own ability to be able to produce the machine per se which captures moisture?
Sure. So in Bangalore today, we have already scaled it to 4,000 liters per day. And we have a facility where we are capturing this and then distributing this water to a lot of our customers, where we have onboarded almost 45 plus customers in Bangalore. The plan from here is to expand to other cities and geographies where we can similarly establish, units, I think, which can make anywhere from 10,000 liters to 50,000 liters per day. And the impact, how we measure is it's a bit indirect, because for every liter of water we produce, we are almost saving 2.5 to 3 liters of groundwater, which otherwise would have got extracted and utilized for many other purposes. So that's an indirect impact, that because of our solution, we are saving a lot of groundwater, which can then be left to nurture overall.
All right.
So I think the expansion plan will depend again on ability to scale and also reduce costs so that wider applications open up. So it's going to be a journey over.
All right. So it's your own challenges to solve for, and we hope you can do that. Final question from Nikhilesh, because you've got the widest technology which can be adopted and is already getting adopted by cities like Hyderabad. How quick, I mean, it is IoT AI based, so you can very rapidly scale. Do you see any barriers at the policy level in adoption?
I would just like to add that we are already over the last 10 years working with 8 states, and 8 states are using our solution. So our solution would be at a state scale, then at a city scale, then river basin scales. So on a state level, we are working with 8 states, 4 solutions are at a country level. And then at a city scale, we are working with 8 cities in Karnataka right now. And from an adoption point of view, I would say awareness is something that definitely is required, that such solutions are there. More often, there is a need to implement. They would like to implement, but awareness lacks.
I'm going to have to conclude there, but thank you very much for sharing your technology with us. And we just need you all to scale up faster so that we do not stare at a water scarce country. Thank you so much, Amrit, Swapnil and Nikhilesh, for joining me. An overhaul of our water governance structure and regulatory structure may help deployment of tech solutions faster. And of course, the tech startups themselves need to get maybe lot more funding to be able to scale up. I'm going to conclude by reminding all of us, India is home to 18% of the world's population. It's also growing, but we only have 4% of the world's freshwater resources. So every drop should matter in your apartment, in your office, in your colony. Capturing rainwater during monsoons, is that happening? Ask that question, and if not, make it happen. Goodbye and thanks so much for watching.